All right, in this video, we're going to do dividing polynomials. And before we do polynomials, I want to remind you of long division that you learned way back in middle school. All right, so if we wanted to do 10 divided by 3, what would we do? We would say, does 3 go into 1? And we would say, no, it doesn't. So I would leave this position above the 1 blank, all right? And then we would move over to the next digit, and then we would say, okay, does 3 go into 10? And we would say, yeah. Well, how many times? Well, 3 goes into 10 3 times. So we would put 3 above the 0 there, and then we would do 3 times 3 is 9, and we would put that underneath, and then we would subtract 10 minus 9, and that would give us 1. All right, and from here, it depends on what you did with it. You might have said, well, this is 3 remainder 1, or you could have also said, well, I want to keep going and get a decimal. So we would have put a decimal here and a decimal here and kept adding zeros as far as the decimals we wanted. So then we would bring this 0 down and repeat that process. All right, and we would keep going. Something that I want to show you as another option is instead of keep going and doing that decimal, you could take this remainder and put it over your divisor. That's this number that we divided by. So instead of calling this 3.3333 and it just keeps on going, we could call this 3, and then my remainder of 1 would be put over my divisor 3. So 3 1/3, which is the same thing as 0.3333 repeating. Okay, so that's just a reminder of that long division algorithm. And now we're going to apply that to polynomials. So if I look at this, the only thing I'm going to look at is this very first term, x. And the only thing I'm going to look at over here underneath is this very first term, 3x cubed. And so I'm going to ask myself, what can I multiply by x to equal 3x cubed? So it's like, what times x would equal 3x cubed? Well, I would have to have a 3 in there, right? And then in order to get x to the 3rd power, I would need to have x squared, so that the total number of x's there is 3. So that 3x squared, that thing that I'm trying to come up with, that goes above here. And then we do that algorithm process. So I would say, okay, now I'm going to take my 3x squared and multiply by that x. So I'm going to do 3x cubed. So we know that when we multiply that, we get 3x cubed. But now I have to multiply by the rest of that polynomial in the front. So I would multiply that also by 3. So 3x squared times 3 would give me 9x squared. And then I would do the same thing that we did up in the whole numbers. I would subtract this. So if I do 3x cubed minus 3x cubed, that's just 0, right? That's nothing. And then if I do 17x squared minus 9x squared, that would give me 8x squared. Now, since I don't have anything to subtract from the 21x or the 11, I just bring those down, just like I would with my numbers, my whole numbers. And then I repeat this process. So I'm going to erase this first 0 since that's nothing. All right, so now I'm going to say, okay, what times, again, I'm just looking at that first term x, and I'm looking at this, this is now my first term, 8x squared. So what times x is going to give me 8x squared? So I would obviously need an 8, and to get to x squared, I would need an x times an x. So 8x is going to go up here, and that would be a positive 8x. And then I'm going to take my 8x, and I'm going to multiply it by my x and by my 3. So I'm going to do 8x times x is 8x squared, which we knew. And then 8x times 3, that would give me 24x, a positive 24x. So now that I've multiplied, I'm going to subtract that. So 8x squared minus 8x squared, that's 0. That's nothing, and I'm not going to write it this time. And then 21x minus 24x, that gives me a negative number, negative 3x. Again, I don't have anything to subtract from the 11th, so I'm just going to bring that down. And now I'm going to repeat that process. So we just keep repeating this process until we run out of terms. Okay, so this is my first term now, and I'm still looking at x. All right, so I'm asking what times x is going to give me negative 3x? Well, the only thing there is going to be negative 3. Okay, so negative 3 times x will give me negative 3x. So that negative 3 is what goes up here. And then again, I'm going to multiply my 3 times x and 3. Oops, my 8x got erased there. Okay, let's see. Okay, so if I do negative 3 times x, that gives me negative 3x. I'm going to put that underneath there. And then negative 3 times positive 3 is negative 9. So now I'm going to scroll down a little bit. So I'm going to do the same thing we did. I'm going to subtract. So negative 3x minus a negative 3x, that gives me 0. And then negative 11 minus a negative 9, that would give me negative 2. Okay, now do you notice how I can't multiply anything times x to give me negative 2? So that's how I know I'm done. And this is like my remainder. Okay, so I'm going to go back up to my answer. So my answer up here, I'm going to erase my arrows. So this up here in blue and in red is my answer, but I also have this remainder of 2. So I'm going to put my remainder of 2 over what I divided by, x plus 3. Remember, that's what I divided by. So I have this thing, and then this is my remainder. Okay, so let's do that one more time, and then I'll show you an even easier way. I know you'll like it better than this, because I know you guys are probably groaning by now. Okay, so we're going to do 2x plus 1 divided into 6x cubed plus 5x squared minus x minus 1. All right, so I'm looking at my first two things. So what times 2x equals 6x cubed? That's going to be, well, 2 times 3 will give me 6. And then x squared times x would give me x cubed. So 3x squared is going to go up here. And we are now going to multiply that by 2x and times 1. So that's going to give me 6x cubed plus 3x squared. I'm going to subtract that. So these are going to cancel and give me 0. 5x squared minus 3x squared gives me 2x squared. And then I don't have anything to subtract here, so these just get brought down. Okay, let's repeat the process. 2x squared and 2x. So what times 2x gives me 2x squared? I already have the 2, so I don't want a number. So I just need a plain old x. All right, so x is going to go up here. And then I'm going to multiply that x. I'm going to do my arrows again. All right, I'm going to multiply my x times 2x and times the 1. So 2x times x is 2x squared. And x times 1 is positive x. And we're going to subtract that. So this gives me 0. Negative x minus x, be careful here, these don't cancel. These actually give you a negative 2x. And then I'm going to bring this down. All right, so we got to repeat this process one more time. All right, so I'm going to underline the first thing in each one. So 2x, what times 2x is going to give me negative 2x? Well, that's just going to be negative 1. So I'm going to have negative 1 up there. And I'm going to multiply negative 1 times both of those. So if I do negative 1 times 2x, that's negative 2x, and negative 1 times positive 1 is negative 1. And if I subtract those, I get 0 on both of them. So this time I don't have a remainder, and this would be my final answer with no remainder, 3x squared plus x minus 1. Okay, so by now you're probably thinking, oh my gosh, that's a lot of work. Is there anything easier we can do? Yes, and this is going to be the way that we try to use most often. So when we're dividing polynomials, we will be using what's called synthetic division. And this is a shortcut to long division. All right, so to help us remember the process for synthetic division, I use the phrase drop the baby mama. All right, so I'll explain that. So the first thing we're going to do is we're going to write the first polynomial in standard form. All right, so do you see how this is in standard form? If any coefficient is missing, we're going to use 0 as its coefficient. All right, so I have 3x squared. The next power down is 1, and I see that that's not missing, so we're good. And then I have 10. All right, so I don't have to worry about the 0 in this particular problem. All right, so I know that that first polynomial is written in standard form, so I'm good there. So all we're going to do is we're going to write the coefficients of the numbers we are dividing by outside of the box. Okay, so here I'm going to show you what the box looks like. So I'm going to draw the division sign, but I'm going to draw it differently. It's upside down. So I'm going to first put the coefficients of this first polynomial up here. And I'm just writing the coefficients, so notice there's no variables. And notice that I used a negative 1 there because that's the number in front of the x, and then a negative 10. Make sure you get the signs with that. Now what goes out here, I'm not going to write this whole thing. Okay, I'm actually writing the opposite of this number. It's like if I had set x minus 2 equal to 0 and solved, we get x equals 2. All right, so that's really why we're doing that. But we're always doing the opposite of this number. And that's what this means, the opposite of the number inside with the x. Okay, so that's your setup. That's how you set up your synthetic division. Now here's where drop the baby mama comes in. All right, so in step 3, we're going to drop the baby. That just means we're going to bring down this first number. So I always encourage you to draw an arrow, and then underneath your box, you're going to just write that 3. Mama stands for multiply, add, multiply, add. Okay, so what are we multiplying? We're always multiplying these numbers outside of the box. All right, so I'll be doing 2 times 3, and that equals 6. My answer goes in the next column inside the box. Whenever I'm adding, I'm always adding the numbers inside the box, so in the same column. So negative 1 plus 6 is going to give me 5. And again, I put my answer below the line. And then I'll repeat that process. So now I'm going to do 2 times this number, 5. So 2 times 5, that gives me 10. And where do I put the 10? I put it inside the box in the next column. And then I'm going to add the numbers in this column. Negative 10 plus 10 is 0. So you keep doing multiply, add, until you run out of numbers. So what does all this mean? What do these numbers mean? Well, any remainder is added at the end and goes over what you divided by. So how do we know which of these numbers is a remainder? This last number, I always like to put a box around it. That's always the remainder. And then I like to work backwards from there. Okay, so the next number over from the remainder, that's always going to be your constant number. And then the next number over is going to be the number in front of the plain old x. And if we had more numbers in front, that would be in front of the x squared, and then the x cubed, and so on. But we don't have that many numbers, so I'm not going to use those in this problem. So my answer would be 3x, okay, I'm doing 3 because that's in front of the x, plus 5. I know to do plus because that's a positive 5. And then I have a remainder of 0, right? So my 0 would normally go over